Okay, let's do number 12 since it's also an ellipse problem. It says find the standard form, which is the x minus h squared, and then we got a plus sign in between, and it's over a squared and y minus k squared over b squared equals 1. Now, sometimes the a squared and the b squared switch places. We always say a squared is greater than b squared. A squared should be the bigger number. So I don't know yet. I think that's going to be okay, but I'm not sure yet. It says, find the standard form of the equation of the ellipse with the given characteristics and the center is at the origin. So if the center is at the origin, which is our HK, that means this is really just x squared on top, because x minus 0 is x, and over a squared plus, and this would be y squared over b squared equals 1, because if k is 0 and x is 0, we really just have x squared and y squared. Okay, it says the vertices are negative 9, 0, and positive 9, 0. Positive and negative 9, and then 0 on the y-axis. So we're going to put our two vertices on our graph paper, and the vertices are always the endpoints of the major axis. So I know it's going to be longer this way, left, right, because the vertices are always the endpoints of the major axis. Then, since, this is correct, I do have a squared is bigger, because here's our center at the origin, and this is a to the left, and this is going to be a to the right because it's bigger. It's going to be the bigger number. So a is actually 9. So a squared would be 9 squared, which would be 81. So far we've already got a little bit of it. X squared over 81 plus y squared over, I don't know what b squared is yet, equals 1. But they do give us the coordinates of the two foci. It says the foci are at positive and negative 1, 0, 1, 0, and negative 1, 0. So that gives you little c. That's the distance. Little c is the distance from our center to our focus. So you can see center to focus would be 1 unit long. So that's little c. We're going to use the formula c squared equals a squared, because it's bigger, minus b squared. You always want to be taking a bigger number minus a smaller number so that you get a positive number, and then you take the square root, so it will make it positive, leave it positive. So we know a squared is 81, minus, we don't know what b squared is, but we do know little c. Little c is 1. So where we have c squared, we're going to put 1 squared, which is 1. So we have 1 equals 81 minus b squared. Subtract 81 from both sides. So we have negative 80 equals negative b squared. Divide by negative 1, divide by negative 1, and it just makes both sides positive. So we know that b squared is positive 80. B squared is what we want, and we know it's positive 80. So that's the equation that we're looking for. That's the equation of our ellipse. All right, let's do number 11 next. And it says find the standard form of the ellipse. So I'm trying to do all the ellipses at one time with the given characteristics and the center at the origin again. So our center, HK, is the origin, 0, 0. So the upper half of our equation is just x squared and y squared with a plus in between. Ellipses always have a plus, hyperbolas always have a minus. Okay, this one's going to be really easy because look at how many we move on the x-axis. We move 5. So underneath the x's squared will be 5 squared, or 25. Look how many we move from the center on the y-axis. We move 8. So underneath the y squared will be 8 squared, which is 64. So we're going to have x squared over 25 plus y squared over 64 is equal to 1. And that is the standard form with the center at the origin, 0, 0, because our h and k are both 0. And we moved 5 on the x-axis, or we could have moved this way too, by the way. We could have moved this way 5. Either way, it's 5. And we could have moved down 8. Either way, it would have been 8 units from the center on the y-axis. So that's it. Number 19 is an ellipse. Whoops, I'm trying to erase. Is an ellipse. I know it's an ellipse because my first indication is I have a plus sign between my x squared and my y squared. The other indication is the coefficients on the x squared and the y squared are different. So if you have a plus sign and different coefficients, it is an ellipse. So let's go ahead and do it since we're doing ellipses. We're going to have to put this into standard form. So we start out 9x squared, that one, and then our x's. So we're going to put plus 72x, and then I want you to put plus a blank. Then we're going to do our y squared. So we have plus 16y squared, then we'll do our y's, plus 32y, and then I want you to put plus a blank, equals. The constant term is a positive 16 on the left side of the equal sign. We're going to move it to the right of the equal sign. So we would have to subtract 16 from both sides. So it'll be a negative 16 on the right, plus a blank, plus a blank. Whatever numbers we add to the left, we have to add the same amount to the right of the equal sign. Okay, before we can do completing the square, which is the blank, we're going to have to factor out the 9. So we have 9 times the quantity x squared plus 8x plus a blank, close parentheses. Same thing for the y's. We'll have to factor out the 16 times y squared plus 2y plus a blank equals negative 16 plus 2 blanks. Okay, to fill the blank, we take half of the b term, which is 4, and we square it. 4 squared is 16. But did we really add 16? No, we added 9 times 16. And 9 times 16 is, whoops, let me clear that. 9 times 16 is 144. So we really added 144 to the left side, so we've added 144 to the right. Now to fill this blank for the y's, we take half of the b term and square it. So half of 2 is 1, and 1 squared, 1 times 1, is 1. So we're going to put a 1 right here, but did we really just add 1? No, we added 16 times 1. Because everything inside parentheses is multiplied by 16, we really added 16. So we have to add 16 to the right. So now we've got 9 times the quantity, x, and it's always going to be half of your b term. So half of 8 is plus 4 squared plus 16 times y, and it's always going to be half of your b term, so plus 1 squared equals These 16s are going to cancel each other out, so we get 144. Now we'll divide everything because remember, ellipses are equal to 1, so we've got to divide every term by 144. 144. So we'll reduce. 9 goes into 9 once, and 9 goes into 144 16 times. So we're going to have x plus 4 squared over 16 plus 16 goes into 16 once, 16 goes into 144, 9. So we have y plus 1 squared over 9 equals 1. That is the standard form. Now we're gonna identify it. It is an ellipse, and we know it's an ellipse because we have a plus in between our x squared and our y squareds, and our coefficients on the x squared and the y squared are different. Okay, I think we're going to have to graph it down below here. Yeah, we have to find the graph. So our center is HK, so it's the opposite and opposite. So -4, -1, -4, -1. That would be right here on our graph paper. That's going to be the center of the ellipse. On the x-axis, we're going to move the square root of 16, because that's a squared. We're going to move the square root of 16, which is 4. So we're going to move 4 on the x-axis, so left, right, 4. So from the center, 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the right. Okay, on the y-axis, the square root of 9 is 3. We're going to move up 3, 1, 2, 3 up, and from the center, 1, 2, 3 down. That's what our ellipse looks like. Center at -4, -1. It's got to be this one. Okay,